All right, you ready for week 2? Hope you survived week 1 and that you found some great number sense building happening in your classroom with your kiddos. So week 2, we are going to be focusing on number relationships. And to me, this was the holy grail of what number sense is. One of the best and most quoted quotes out there about number sense talks about it being a good intuition about numbers. I'm like, what? So what exactly is that? And how do I teach that? It always bugged me. But when I read John Vandewall's book, Teaching Student-Centered Mathematics, it was like, that light bulb of being able to see these 4 relationships and knowing that's what those kids are missing. That's the intuition that kids who have number sense have, and those who don't have number sense are missing these 4 things. So that's what we're going to talk about today. Brief little overview of those 4 things. Then we're going to dive deeply into one of them. So before I forget, don't forget to download your workbook if you haven't done that yet. There's a link on this page for the workbook. Also, if you missed out on week 1 or the intro about me, so you know who I am, there's links to those videos as well on this page. So if you haven't done week 1, you can go back and watch that info as well. But if that's too overwhelming to do 2 weeks of challenges, you can just start off where you are right now with us on week 2. You don't have to know the prior stuff to be able to do week 2. I mentioned 4 number concepts. The first one is spatial relationships. This ties to last week's information about subitizing, which is being able to see how many without having to count. So spatial relationships is taking the relationship of like, this is 4, but also knowing how it relates to other visual patterns. So this is 4, but this is 5. How do they relate to each other, right? That's a big part of spatial relationships, is looking at how amounts relate to each other, but having a visual. Because if I just give you the digit 4, the digit 5, and then you ask me how are they related, there's nothing there that really gives me any of that info. So spatial relationships is giving them a visual to then talk about how amounts and quantities relate to each other. The second number relationship is 1 and 2, more and less. This is when kids can instantly tell you 1 more, 1 less, 2 more, 2 less. And we got a lot of kiddos who can't do that. The third number sense relationship that Vandewall talks about is the benchmarks of 5 and 10. Because this is important because we are a base 10 system and 2 5s make up a 10. So it's really important that kids understand how numbers relate to those benchmarks of 5 and 10. And I'll give you a little bit more insight into that one because that's the one we're going to dig a little bit deeper into in just a few minutes. So the fourth one is part, part, whole. And that's knowing that a number can be broken down into parts, but also parts come together to make a whole. That's a big deal around number sense as well. Some people call that decomposing and composing, and that's a big idea all through kids' mathematics education, is being able to break apart numbers and put numbers back together. So let's spend a few more minutes talking about benchmarks of 5 and 10, and then I'll give you your challenge for this week.
This week's challenge centers around the benchmarks of 5 and 10. Now, basically, what it is just that kids need to know how a number relates to 5 and how it relates to 10. So if I was thinking of the number 7, I don't want kids to just know it's 7 things. It's not just 1, 2, 3, 4, 5, 6, 7. I want them to understand how it also relates to 10. How does it relate to 5? How far away is 7 from 10? How far away is it from 5? And that's what relationships are all about, right? It's not just that 7 is 7. It's how is it connected to other numbers, but specifically those benchmarks of 5 and 10. Now, I've known that 10 is a really powerful number for a long time, and because we have a base 10 system. And the more I really started digging into pre-K to second grade, I realized fiveness and how a number relates to 5 is maybe even more important than tenness, like how a number relates to 10. And the more I started digging into it, I found that it is just so cool how numbers relate to 5 and 10 and how powerful that can be in everything that we do, not just with small numbers, but as we work our way up, being able to relate to those what I call decade numbers like 20 and 30, and then as it moves up into our hundreds, how far to the next hundred, and so on, those become really, really powerful. But one of the coolest things I ever found, this was like a light bulb moment for me, is why it's so darn important that kids have both 5 and 10 is this fact right here. If you understand how a number relates to those benchmark numbers of 5 and 10, which then translates into 15 and 20 and 25 and 30 and 35 and so on, that no number that you ever deal with will ever be more than 2 away from a benchmark. Now I'm talking about whole numbers here, right? But no whole number will ever be more than 2 away from a benchmark. And I thought, oh my gosh, that's like that's so cool. And it took me a while, like I started playing around with it, right? So if I'm thinking about the benchmarks 0, 5, and 10, right? And I think about the number 3. Well, it's 3 away from 0, but it's only 2 away from 5. If I think about 2, well, that's 3 away from 5, but it's only 2 away from 0, right? And as we move up into larger numbers, if I think of 23, well, that's only 2 away from the 25, right? And 22 is only 2 away from the 20, right? So no number is ever it's never going to be more than 2 away from a benchmark, which is why we don't want kids counting more than 2. Like if I'm at 23 and I have to add 5, I don't want them to count on 5 one by one by one. I want them to chunk and be like, well, 2 more would get me to 25, get me to a benchmark, and I just have 3 more, and that will get me to 28. We want them to use those benchmarks to be able to chunk, right? That's what we do in reading. We want kids to chunk stuff. We don't want them sounding out words letter by letter by letter. We want them to see the friendly amounts within within the words. And that's the same thing when it comes to numbers. We want kids to see those friendly chunks. What would be friendly and help me get to something that I know, right? So it is super important that kids understand 10, but I think even more powerful is how a number relates to 5, because then no number is ever more than 2 away from a benchmark number. It's really important. Okay, so how do we help kids build those experiences? What kind of experiences can we build for our kiddos? Now, remember, in all of these experiences, I don't want you to think you have to do like a full 45-minute lesson on these things. Just take 5 minutes here and there and add stuff in. And today's experiences, well, I guess this week, but today what I'm going to talk to you about is I really want you to start using structured manipulatives. So here's why structured manipulatives are so important. If you just think about our standard manipulatives that we use, like the Unifix cubes, right? If a kid counts out these 6 blocks, they don't really learn much about what 6 is, except that it's 1, 2, 3, 4, 5, 6, right? But as they're counting out those 6 blocks, if we have them actually place it into a 10 frame, they learn a whole lot more about that. So they do count, they get 1, 2, 3, 4, 5, 6, but then once it's in this 10 frame, there's a whole lot more that kids start to discover and that we as teachers can help highlight and make explicit if they don't see it right away about what 6 is. It is 6 things, but it's also 1 more than 5. It's also 4 away from being a full 10, right? So putting things into a 10 frame is a structured way to use your manipulatives. You can put them into an empty 10 frame and have the kids fill the 10 frame. You can also give them 10 frames that have amounts in there, right? Another popular structured manipulative is the Reckon Rec. It's also known as a math rack, a number rack, an arithmetic rack, and on and on. I think it's got, I don't even know how many names, but no matter what names you call it, it's this. It's beads on two rows, and those beads are different colors, and the color matters. The change of color happens at 5, so I can use that change of color to help me. So it's again, this tool emphasizes the fiveness of a number, not just tenness, but I can really use fiveness to know that that is 6 without having to just count 1, 2, 3, 4, 5, 6. Or even if I do count 1, 2, 3, 4, 5, 6, once I've got it, now I can start noticing something about 6 that I can't notice if I just have unstructured manipulatives sitting on my table. So use structured manipulatives. That's your first thing for experiences that I want you to provide for your kids. Another form of structure or visual that helps bring out the benchmarks of 5 and 10 can be a number path or a number line. Now, really quickly, but number lines really don't they're not really the best thing for kindergarten, first grade kiddos. So in a number line is a measurement view of a number. So for a kid to know where 5 is on this number line, um, there's either two options here. They just know it's 5 because they look at the digit, which if they're looking at the digit, that's all they know about 5 is the digit. They don't see a quantity of 5. If they're actually trying to find a quantity and they're actually trying to count stuff, we see them getting it wrong because they will count the tick marks and they'll go 1, 2, 3, 4, 5. And there's 5 tick marks, there's 5 things right there, but that doesn't get you to where 5 is. So it's a really confusing tool for those young kiddos. So instead, the recommendation is a number path. Now, the number path, the only difference is you have these squares or rectangles, depending upon how your number path is made, that associate with the number. Now, a word of caution here. Most of the time when kids and even adults start using a number path, they use it incorrectly. So if I want kids to show me 5 on the number path, and I've done this with lots of adults, and every time they do the same thing, they will circle this. That's really not 5. That's the digit 5, but that's not a quantity of 5. And so on a number path, when I ask my kids to show me 5, I want them to show me 5 things. That's the whole point, is I want them to associate the number 5 with the quantity of 5 things. And the number path helps us do that. Now, in a number line, it's there. There are 5 things there, but like I said, it's a measurement view. 5 is really the distance from 0 to 5. So in a number line, there are those 5 things. It's just that distance. It's that span between the numbers, and that's harder for kiddos to see and visualize that. So the number path is, I start using it with my kids before they're even in kindergarten. My own personal children have been exposed to a number path. I think pre-K all the way through about towards springtime of first grade, and then we can start transitioning from a number path to a number line. But another cool thing about number paths is that even when they're in here, if you notice, these are ones that I've created, and there is a download on this site below the video where you can access a download to print your own number paths. And this is what they look like once you print them out. And there's different colors, and the colors are to help associate where 5 groups of 5 are and then where groups of 10 are. So it's really cool that once you show 9, it helps them see that 9 is just 1 away from that big benchmark of 10. Or even as you go bigger, if I'm showing 17, right, it helps me to see that 17 is 2 away from 15. So between number paths and number lines and 10 frames and rec and recs, I hope that you've seen some ways that you can structure amounts to help kids see the relationships to the benchmarks of 5 and 10. And that's what this week's challenge is all about. I challenge you to incorporate one of those ways to use structured manipulatives or structured tools. So maybe you're already using 10 frames. Well, try out the Reckon Rec or the number path. And then next week, we're going to be talking about how to use these manipulatives even more effectively with a new twist that I have on the CRA model. And if you don't know what CRA is, then make sure you come back next week. Good luck with this week's challenge, and what I'd like you to put in the comments below is which of these structured manipulatives are you going to implement into your classroom this week?